students. From last class onwards we are discussing about motion. Okay, so in this topic let us discuss today acceleration. Means change of velocity or change of speed. What is correct? Means change of velocity or change of speed. What is correct? It's a change of a velocity. Okay, so rate of change of velocity is called acceleration. Okay, so this is correct, rate of change of velocity. How do you accelerate a car? Let us discuss first. How do we accelerate a car? How you will change the velocity? Okay, so there are three ways to accelerate a car. Okay, so we are discussing how do you accelerate a car. So to accelerate a car there are three ways. Okay, so first one is press the accelerator. You know very well, I think you know very well about a car. Okay, you can see the accelerator. Okay, if you press the accelerator, okay, so when you press, this car goes with a high speed, right? Yes or no? Okay, so there are three ways to accelerate a car. Okay, first one is press the accelerator. Okay, so when you press, this car goes with a high speed. Okay, so velocity is speed with the direction, right? Yes or no? Okay, so speed is magnitude of a velocity. Okay, so changing acceleration means either increasing or decreasing the velocity, right? Yes or no? Change is nothing but whether it is increasing or decreasing, you can take. So if you press the accelerator, what happens? Your speed increases. Okay, suppose you are going with the 20 kilometers per hour. If you press the accelerator, you will go with a high speed. Okay, here we are increasing the speed by pressing the accelerator. Okay, so this is a one case where we can accelerate the car. Okay, so here velocity is nothing but velocity is nothing but speed with the direction, right? Yes or no? Speed way plus direction. Okay, so change is nothing but change in acceleration means either increasing or decreasing. Here this if you press the accelerator, here increases. Okay, so next case is brakes. If you apply the brakes, what happens? By brakes. Okay, so by applying the brakes we can decrease the acceleration. Okay, this is negative acceleration. Oh yes or no? So by applying the brakes, what happens? If you apply suddenly brake, it will take a few seconds or uh, even a minute to come into stop position, right? Yes or no? So here this is negative acceleration. If you apply brakes, what happens? It will stop, right? This is negative negative acceleration. It is also called a retardation. Okay, retardation. Okay, negative acceleration is also called a retardation. Okay, so if you apply the brakes, what happens? After a few seconds it will come into rest. Okay, yeah, we are decreasing the speed, means negative acceleration. It is also called a retardation. Okay, so retardation. Next, third way. What is the third way to accelerate a car? Change the direction. Okay, so third way is change the direction. So if you change the direction, automatically the speed will decreases, right? Yes or no? Okay, so changing the direction, let us consider some examples to identify whether that is acceleration or not. Okay, so before that, how do we accelerate a car? By three ways. There are three ways to accelerate a car. Pressing the accelerator to increase the speed. Okay, so next applying the brakes, here we decrease the velocity, means negative acceleration. Okay, we are decreasing the acceleration, that is also called as retardation. And next one is changing the direction. Okay, if you change the direction, even we can it will alter the velocity, means you will decrease the speed, okay, while changing the direction. In these three cases we are changing the velocity, means we are altering the acceleration. Okay, so these are the three ways to accelerate a car. Okay, so let us discuss some examples. Okay, where let us check whether they are in acceleration or not. Okay, first one is a car going at a constant speed in a straight line. Okay, so first examples, let us discuss some examples. Okay, first one is a car going a car is going at a constant speed in a straight line. Okay, so your constant speed and straight line means the direction is constant, right? Okay, here see, speed is constant and direction is also constant. It's nothing but velocity is constant or not. So car going with a constant speed, and even straight line means direction also constant. Okay, so speed with a direction is called velocity. So here constant speed and constant direction means nothing but a constant velocity. Here, is there any change in velocity? No, no change in velocity. No change in velocity means, is there any acceleration? No. So in this case acceleration is 0. So is this car accelerating now? No. Okay, so acceleration is 0. Okay, so a car going at a constant speed in a straight line, then there is no acceleration, means acceleration is 0. Okay, so let us consider second example, dropping a pebble into water. Okay, dropping a stone or pebble into water. Dropping a pebble into water. Okay, here what you are doing, you are dropping a pebble. Okay, you might have played. Okay, so you are dropping a pebble into water. What happens here? Is this acceleration or not? Let us check. So while dropping, before dropping, initial velocity for the pebble is 0, right? Yes or no? Initial speed. Okay, initial speed or initial velocity is 0. Okay, so when it hits the ground, speed is greater than 0, right? Yes or no? So initial velocity is 0. Okay, so when it hits the ground, obviously this speed is greater than 0, right? Yes or no? Okay, so means final velocity, okay, or final speed. Okay, so when the ball hits the ground, then what happens, the speed is greater than 0, right? Obviously. Okay, so due to the earth's gravity, the speed of the pebble increases, right? Yes or no? So here let us this is a case of freely falling body. Okay, so at that time what happens, first pebble attains the speed because earth gravity continuously drag these pebble or stone towards its towards its center, right? Yes or no? So what happens, the speed obviously greater than 0. So speed is greater than 0 means here accelerating or not. So dropping a pebble into water is a examples for accelerating body. Okay, here acceleration is there. This is a examples for acceleration, dropping a pebble into water. Okay, so next let us consider one more example, catching the ball. Okay, catching the ball. Let us consider in a case of cricket. Okay, so a bowler, okay, so you can see catches, right? So while catching the ball, So is this example for acceleration or not? Catching the ball is example for acceleration or not? Okay. So when you are catching the ball, initial velocity. So already the ball is moving with the some velocity, right? Okay. So initial velocity here is not zero, right? Initial velocity is greater than zero, right? Yes or no? Okay. So here also you can consider velocity and velocity. Here initial velocity is greater than zero, right? Yes or no? When the time of catching, okay, after the catch the final velocity will become zero because you are catched now, the ball is there in your hands. Is that ball is moving? No. So final velocity is zero. Okay. So is this ball is accelerating or not? It is accelerating. Okay. So it is a case of retardation since the speed of the ball is decreasing, right? It's already moving with some velocity, you are catching now. So what happens here? The speed of the ball is decreases, right? So it is a case of a retardation. Okay. So because speed of the ball is or velocity of the ball is decreasing, okay, as this is a case of a retardation. Okay. So next, throwing a ball upwards. Okay, throwing a ball upwards. Fourth example, okay, so you are throwing a ball up. So is this ball accelerating or not? Okay, so let us consider. So when you are throwing a ball, you are giving some speed to the ball, right? Yes or no? Okay. So if you apply some force, then only the ball move upwards, right? Yes or no? So here you are giving some velocity or some speed. Okay. So initial velocity or initial velocity is greater than zero, right? Initially you are giving some velocity, then only it will move upwards, right? Okay. So initial velocity is greater than zero. Okay. So speed at the top, okay, when it reaches maximum height, what happens at the time? Speed, okay, initial speed or initial velocity. Okay. Here speed at the top is zero. So here this ball is moving with some velocity upwards. What happens at the some point? It becomes zero. Means here it is retarding, right? Okay. It is a case of a retardation. Means initially it is moving with some velocity. Finally it is decreasing, right? This is a case of retardation. Next, what happens again? It will come backwards, right? Yes or no? Due to the acceleration, due to gravity, right? Okay. So the speed increases, right? Yes or no? Here 0 and it is increases. In this case, what happens here? It is accelerating. Okay. Okay. So clearly you can see, you can observe, right? When the ball is going upwards, it is a case of a retardation. When it is coming downwards, it is a accelerating. Means speed is increasing. Here it is at top, at maximum height it is 0, right? So now while coming back it is increases its speed. It is a case of acceleration. Okay. So you clearly understood, right? Its gravity constantly pull the ball downwards, so the speed of the ball decreasing at the time of going up, and while coming down it will increases. Okay. This or no? So this is a case of both. You can observe retardation and as well as acceleration in this case. Next, try to observe one more. A ball moving in a circular circle. Okay, ball is moving in a circle, constant speed, with a constant speed. Ball moving in a circle with a or constant speed. Okay, so is this accelerating or not? Okay, so speed of the ball constant, right? Yes or no? Here it is moving in a circular path. The speed of the ball is constant. Okay. Okay, suppose is this velocity is constant here? No. Okay, so let us consider this ball is moving like this, okay, in this circular path. So it's continuously changes its direction, right? Yes or no? So it's changing its direction means is this velocity is constant? No. Okay, so velocity is not constant here. Why? Because here the ball has to change its direction continuously to travel in a circular path. That's why velocity is not constant. Okay, so constant ball continuously changes its direction. This is the example for accelerating motion. Okay, so accelerating motion. Okay, this is example for accelerating motion. This is also called, this motion is also called, this motion also called uniform circular motion. Okay, uniform circular motion. Okay, so this motion is also called a uniform circular motion. Okay, so you know, understood, right, about acceleration clearly, how do car attain acceleration? Okay, what is retardation? Okay, so with the some examples you understood clearly about acceleration, right? Okay, so acceleration is change of velocity, right? Okay, so it is also called a rate of change of velocity. Okay, acceleration is nothing but a rate of change of velocity. Okay, so rate is nothing but divided by time. We already discussed in a previous class, right? Rate always, wherever you can see the rate, it's nothing but divided by time. Okay, so acceleration, small a, it is indicated by small a. Acceleration is nothing but a change of velocity, of velocity by time, right? Okay, yes or no? Rate of change of velocity is nothing but formula change of velocity by time. Okay, so let us say a body is moving with the initial velocity u. Okay, so a body is moving with the initial velocity u, and it attains, okay, so and it accelerates to final velocity to accelerate to final velocity v in a t seconds time, t seconds. So what is acceleration? Now find the by using formula. A is equal to final velocity minus initial velocity by time. Okay, so this is the formula to find the acceleration. Okay, so here a body is accelerating with the initial body of initial velocity u accelerating to the final velocity v in a time t seconds. Then acceleration is equal to v minus u by t. Okay, so what are the units? Meter per second square. Okay, because here how we got these units, let us see. Already in upper velocity, right, velocity units a meter per second, right? Again time t, so that is equal to meter by second square. Okay, this is the units, SI units of acceleration. Okay, so let us take let us discuss some examples so that you can clearly understand how to solve, how to we use this formula in solving problems. So let us say example 1. Let us take a car. of a car velocity, initial velocity, u is nothing but initial velocity 0 meter per second. It took 5 seconds to attain the acceleration of 10 meter per second. Okay, so it took 5 seconds to accelerate to final velocity 10 meter per second. Find A. A is nothing but acceleration. Okay, here u, initial velocity is 0 meter per second, right? So it attained final velocity of 10 meter per second in a time of 5 seconds, right? Yes or no? So try to apply the formula. A is equal to v minus u by t. V is nothing but here 10 minus 0 meter per second by 5 seconds. Okay, so 10 meter per second by 5 seconds, 5 to the, so that is equal to 2 meter per second square acceleration. So clearly you understood clearly, right? Okay, like this we use the acceleration formula to find the acceleration. Okay, if the body moving it attains some acceleration in some amount of time, you will get these examples, these type of problems in your exam. So try to understood clearly, and if you get any doubt, try to revise the video and understand clearly. Okay, so next example, let us see. So yeah, here acceleration is also a vector. Okay, so acceleration is a vector. Vector is nothing but it has both the magnitude and direction. Okay, so means the same direction as a velocity. Here you can see plus value, right? If nothing is there means a plus. So plus 2 meter per second means it is the this car is moving in the same direction as it is accelerating in the same direction as velocity. Okay, so plus means same direction as velocity. Okay, this acceleration you may get in negative. If you get a negative value, then it is a case of a retardation. Okay, clearly remember this clearly. Okay, so next, so let us see one more problem. A car is moving with 10 meter per second and brakes are applied. Car comes to rest or stop position in a 10 seconds. Okay, find the acceleration, find A. Okay, so here initial velocity is 10 meter per second, right? Already the car is moving with the velocity of 10 meter per second. Okay, here it is coming into rest, means final velocity is equal to 0 meter per second. It is attaining or it is coming into rest position after 10 seconds. Okay, time is equal to 10 seconds. Apply formula. A is equal to v minus u by t. Okay, so v is here 0 minus 10 by 10 meter per second by 10 meter per 10 seconds, sorry. Okay, so minus 10 meter per second by 10 seconds. 10 ones are 10 ones. So here minus 1 meter per second. Here you got a value as minus. Minus means it is a case of a retardation. So direction is opposite to the direction of a velocity. Okay, here direction is opposite to the direction of a velocity. It's a case of a retardation. Okay, here the speed of the speed of the car is decreasing, right? So it is a case of a retardation. If a body is in acceleration, whether it is uniform or not, uniform or non-uniform motion, you got a doubt, right? So if the body is in acceleration, whether it is uniform or non-uniform, it is non-uniform, because here velocity is constant, right? In uniform motion velocity is constant. If velocity is constant, means it is changing its direction or not. If a body in acceleration, it is it's obviously non-uniform motion, because in uniform motion velocity is constant. Velocity is constant means it is not a acceleration. If there is either increasing or decreasing in velocity, then it is said to be accelerating, right? The body is accelerating. So acceleration, if the body is in acceleration, means it is in a non-uniform motion. Okay, it is in non-uniform motion. Okay, so uniform acceleration, let us see some examples for uniform acceleration and non-uniform acceleration. So falling, see, a ball is falling. Okay, falling a ball is an example for uniform acceleration or non-uniform. Let us consider, you know, gravitational constant, right? What is gravitational constant value? See this uniform acceleration and non-uniform acceleration, let us discuss in next class, because this class timing is almost 30 minutes. Okay, so I'll get a problem in uploading if I make more than half an hour. Okay, let us wind up this class now itself. Okay, in the next class we'll discuss uniform acceleration and non-uniform acceleration examples. Okay, where there exist uniform and non-uniform acceleration in real life or not. Okay, so try to observe the worksheet timings. Okay, so worksheet is available. See, there is no fixed slot for a worksheet of a physics. Okay, so it's after 1 p.m. before 3:30 you will get a worksheet. Okay, so in any half an hour, either from 1 to 1:30 or 1:30 to 2 or 2 to 2:30 or 2:30 to 3 or 3 to 3:30. Okay, in this, between these time you will get a worksheet. Try to do the worksheet and compulsory submit your worksheet. Okay, so these are the very important concepts. These are helpful if you take even BPC or MPC in your future. It will be very useful. Physics is compulsory. Okay, so try to learn. If get any doubt, try to revise the video. You will understand the concept clearly. Okay, thank you.